Hi everybody. We're going to start today the series of signal classification. The signals can be classified according to many factors. The first, we can classify it according to the time. So it can be continuous time signal or discrete time signal. And if we classify the amplitude, we have two signals, analog signals and digital signals. And for certainty, it can be the deterministic signal or random signals. For time period, there is periodic signal and aperiodic signal. For symmetry, you can have odd signal or even signal, and for energy, you can have energy signal or power signal. So we're going to explain each one separately in different or separate videos. I'm going to collect time and amplitude only in one package, and we are going to see what are the types of signals according to these two factors. In general, the time can be continuous or discrete, and the same thing, the amplitude can be continuous or discrete. So if you have a signal which is continuous time and continuous amplitude, this signal is called analog signal. If the time is continuous but the amplitude has discrete values, it will be called quantized signal. And if the time is discrete and the amplitude is continuous, it's called sampled signals. And if you have both, the time is discrete and the amplitude is discrete, it's going to be called digital signal. Let's just explain it a little bit by using some graphs. What you have here, the one to the left, this graph, you observe that the time is continuous and the amplitude is continuous. What does it mean? It means at any instant of time, you can find the amplitude, and the amplitude can take any value. There is no restriction on the amplitude. You just take any values. So you observe here, the time, it's in this graph, it's from 0 up to whatever the value, infinity, for example, and you have all values of time there. And the magnitude, also we have all values available for you. So we call this one continuous time and continuous values for the amplitude, which is called analog signal. And we have many examples like that, like electric current or voltage signal. All they are examples of analog signal. When you go for continuous time signal, this one, it's continuous time signal. It means that the time can take any value, no restriction on it, continuous time. But the amplitude, as you see, is quantized. It takes level. It doesn't take all values. For example, if you look at the broken line here, you'll find that this is the analog signal. It can take any value. But for the quantized, you will see here, it's taken this value along this level, but does not take any other value between this point and this point. And you go to the second point, all these values are not there because it will be constant for a while till the other level appear again. Maybe it's not clear now. Let me just take an example and see how we do it. This signal is called analog signal. The time, I have it here from 0 to 8, to 6. And the amplitude from 0 to 7. What does it mean continuous time? It means that the time can be taken any value from 0 to 6. You can have 0, 0.1, 0.15, any value between 0 and 6, you can see it. It's there. And the amplitude, it's changed from 0 up to 7. You can have all values between 0 and 7, no restriction on it. How we can make this quantized level? Well, let's see that we have discrete level at 1 and 2, 3, 4, 5, 6, 7. Let me make it a little bit clear. If you make the level here, that's level 1 and level 2, level 3, level 4, 5, 6, 7. What does it mean? It means now I'm taking discrete values for the amplitude. However, I'm keeping the time continuous. So let's now sketch the quantized one. 0 will continue 0 up to the second level when it starts to appear, which is 1, when the voltage get 1. So it will jump to 1. So it stays 0 and then jump to 1. And 1 will continue till the level 2 appear, then it will jump to level 2. And then it will continue till the other level. You see? So now, I mean, the amplitude of the signal between 0 and whatever the time here, it stay at 0. And then when the other level appear here, 1, so it will be jump to 1 and continue till the second level, level 2, and then 3, and then they will continue up to the level 4, then jump to 4, and then it will continue up when you get this level, and that will continue till the other level. So you see, it's just discrete values of amplitude. And this one, it will continue till it reach this level, and this one continue till the second level here, and this one continue always to the right till the following level appear. Then it will jump down over there and continue till you get this level. So it will be like that. So just let me make it clear, it will be steps like that, and then it will continue, be continuous till it come the other level. And so what we did here is like, that's quantized. The magnitude is quantized, the amplitude discrete value, but it has all values of the time. It's time continuous. So that's a continuous time signal, but the amplitude is not continuous. It's discrete, has discrete values, quantized. So that will be quantized continuous time signal. Let's call it quantized, but still continuous time signal. And the one before, like this one, that's also continuous time, but this is analog because the amplitude take all values, not discrete like this one. That's what I'm trying to say. So that's the continuous time signal, but quantized. Now let's just go for the sample. How we make the sample? The sample, you have discrete time signal. At certain instance, like 0, the value is 0. And then 1, at 1, that's the value. At 2, at 3. So are taking sample at each instant. So we call what we have here sampled. That's discrete time signal, but we call it sampled signal. And you observe here, there are values for the amplitude at specific instant of time. Like at 0, you have value 0. At 1, you go there and see what is the value. At 2, and so on. But between 0 and 1, you don't have anything. There's nothing here. This one is not there. It's not there. Just what I sketch, this is the value of the sample signal. So you have only values at specific time instant. That's a discrete time signal, sample signal. But of course can take any value of the amplitude. Okay? So the amplitude continuous, but the time is discrete. What about if you get this sample and you quantize? Let me take another graph. If you go there and let's say, oops, sorry. So let's take at 1, and then you're supposed to go here if it's sampled. But if you quantize also the magnitude, it will not reach here because it's here. There's no amplitude. The quantize at 1, 2, 3, 4, 5, 6. So you will just draw the line up to the level here. All right. Let's go for 2. 2. Well, lucky because it intersects the curve and also the level. So you'll have it there. 3 will be the same thing. 4, you go up to the level. 5, you go here. You don't go to the curve because that's the point supposed to go. You will not go there. Why? Because it will quantize the level. So you got one level here and one level here. So you'll go there. This is closer to this one. All right. And 6 will be 0. So when you take the sample signal and you quantize the magnitude, you call this a digital signal. So now we know the difference between the 4 types of signal. That's the analog signal, continuous time, continuous values. This one quantized signal, which has continuous time, discrete values, and this one sample signal, discrete time and continuous values. And the last one, the digital signal, which is discrete time and discrete values. Okay, thank you, and we'll see you on the second bit.